in the morning, we had a presentation which made me more feel like the book of Yuval Harari, I think the first presenter, who talked about the 20 lessons of the 21st century. He's talking about how the AI landscape is sort of evolving and what are some of the things, good things that are happening or some of the things that we need to be careful about. That is one part of it. Now, in the next presentation, I think we came a little lower in the ground where we talked about external data, how important it is depending on the various use cases, and how we should go about in getting the data and democratizing the data, and then using it for various use cases within the company, and what sort of organizational structure we should think about. What I am going to talk about today is something very basic. So in my last, I have been in American Express for more than 20 years now, and you know, if the first 75% of that time was spent more on the risk decision science. And I think some of you who attended the presentation yesterday, you must have heard this from my colleague Shankara, who talked about the fact that our customers, who are millions of them, more than 100 millions of them, they make more than 7 billion transactions a year. And each of these transactions is stored in our system. And this is possibly the best source of data you can think about. By the way, I'm not trying to belittle the fact that we don't buy external data. In fact, we buy external data worth hundreds of millions of dollars every year, and something which has been done in a very systematic way within the company, which can be accessed by the entire, by all the views for that matter. But today, I'm not going to speak about data. I'm going to speak about how we are harnessing that particular data to work on marketing use cases on a very sort of, in a very sort of a realistic way. And it's not that something what we are talking about is you have not heard about, but something which is very simple, but evolving at a very fast pace, whereby we are moving to a cutting edge scenario. Oh, this is my career journey, very, pretty much have been in this company for the last 20 years, and always move to a new assignment every few years. And in the last 4 or 5 years, trying to sort of dirty my hands in the world of marketing decision science. Next slide, please. Oh, sorry, I have to do it. I think all these data are something which is bragging about my company, but the data which I would like to point to is that this 120 plus million card members or the customers that we have at this point of time, this is a very important information, because that is something I would want you to, the only information I would like you to retain from this particular page is that 120 plus million card members that we are talking about out here, okay? This is the talks about that we have been, we have not been very public about it. We have been media shy, but we have been a company where essentially we have understood the power of the data that we have, and we have started this journey of machine learning AI way back in 2014 and 15 when we set up the AI labs in Bangalore, and then subsequently went ahead and applied machine learning techniques to solve the fraud problem to start with, and then gradually in credit risk, and now in the course of the last couple of years, extensively in the world of market risk. This is what Shankara talked about yesterday, and the evolution of AI ML usage in the context of marketing decision science is what I am going to talk about today. The first is the case of recommender system. Yesterday, somebody did talk about the fact way back in 2006, this recommender system problem was posed by Netflix, $1 million prize. Support vector machine was used to solve that particular problem. The solution was so complex. I think that is a good point that was made yesterday. The solution was so complex that it was not something which could be implemented in the system readily. And finally, they came up with a solution which is more implementable. So if you look at a recommender engine problem, finally, what it boils down to, we have more than 100 million merchants. So that is a starting point, that we start with 100 million merchants. And for an individual customer, the question boils down to how do you go about and rank order that merchants in a meaningful way using some basic machine learning techniques that is there on the left part of the page. Next comes the fact that once I have rank ordered the merchant based on certain heuristics, what is the specific business objective that I need to have in mind, for which I need to take those millions of merchants and sort of take the problem to a much more smaller problem, a more dimensionally reduced problem, with which we can go ahead and address the important business situation. In other words, I take those millions of recommendations and then finally boil down for the card member to a few hundred recommendations which I need to come up with, and then sort of stop there and then figure out for the specific card member what is that exact merchant recommendation that I need to make at that particular point of time. And then the final point, last mile attribution, which essentially talked about the fact that from that 100, now I need to come up with 3 or 5 merchants which I need to recommend in that app or in that Mica page, which is the American Express Mica page, recommending the card member that this is a place, why don't you go and try to use our American Express card. Now, this is something which is happening in the world of Amazon, in the world of Netflix, in the world of all companies. But in the context of the problem that we are talking about, think of the dimension of the problem where we have more than 100 million customers and we have more than 100 million merchants. That is, and for each of the customers, we have all the details of the data of the 7 billion transactions all these customers have made. That information is there, and that information is embodied in this 100 million cross 100 million matrix. And this matrix is a matrix which has a time dimension to it. So it's not a 2-dimensional matrix, it's a 3-dimensional matrix. And this is the data that needs to be synthesized in a meaningful way, in a very clear way, so that we can go ahead and finally come up with those few recommendations. So that is essentially the business problem that we are trying to solve, but in a very practical way. So I don't want to leave you in the air saying that this is how we need to go about solving and we applied some very funky technique. That's not the case. How we went ahead and demystified the problem and solved for American Express is something I'll try to give you a few snippets about it. So the problem statement is that merchant recommender at American Express tries to solve 2 specific problems. This is where the business problem comes into place. The first problem that we are trying to solve is to ensure the fact that we improve the perception of coverage. Now, this is a criticism which we have faced for long years, where essentially we have said that American Express, particularly in the market for US as well as the international markets, is not accepted at a very high with a very high sort of frequency as it is the case in the case of other sort of other cards like Mastercard and Visa. Now, we took it up very seriously. There's a separate team that is working in trying to ensure that the coverage is sort of increasing. And at this point in US, as per the latest numbers that I have, we stand somewhere in the range of 88 to 90% in terms of our coverage at this particular point of time. But beyond that, the question that boils down to the fact, for the card member, the question is that I want to give the card member the feeling that the card is used beyond his or her favorite store. And on top of it, also have the overarching vision that along with the fact, it should also go about in increasing the amount of spend the card member can possibly bring as a part of the American Express enterprise. Now, this is something which we are trying to do every day for all our card members, keeping this merchant data and this card member data interaction, which I talked about just in the previous page. And it boils down to something very significant. It boils down to 1 billion recommendations which we are making to our card members throughout the course of the year. And this drives billions of dollars of spend for the company. I think yesterday you must have heard Shankara talked about the total amount of spend our card members make is of the order of $1.3 trillion. So this is big business that we are talking about here. Through this process, we are trying to go about in doing it. Now, how is exactly we sort of break this problem now to something really pragmatic, which we can solve in clear steps? So this is the way, this is actually, if you can think about it, a sort of a blueprint, the way currently we are solving that problem. The first question is that how do we take those millions of merchants and then break it to a problem whereby we have come to a manageable list of 200 to 500 merchants. Now, how do I do that? We essentially do that by trying to first understand where is this candidate, where is this card member located. Now, that is something you might say, you know what, why didn't I use the billing information? We can do that, but that used to be in the time prior to COVID. But now, given the fact, because of COVID, people have gone ahead and moved from their current location to some other location, as a result of which your billing address, your billing zip is not something which essentially at all points of time gives a very adequate representation as to the place where you are currently staying. So we have to use information as to where you are logging in from Mica and other pieces of information as to where you are transacting in which location to get a very fair idea as to high likelihood as to where currently you are residing, and based on that location, how do we provide you with the right recommendation as to which set of merchants you want to talk about. Just to specify, is to start with the problem, we are talking here of brick and mortar merchants. We are not talking about online merchants in this context of this discussion, while in the context of online merchants, this particular algorithm is being modified as we speak at this point of time. So if the billing zip is where the card member is staying at this point of time, that is not a very difficult problem for us, because we are trying to figure out within the 5 to 10 mile radius what is the right recommendation of the specific merchant that we can suggest. But in the context when the person is not in the billing zip, we need to infer about that based on where the customer has transacted in the past, and then from that particular point infer that information and then suggest the necessary zip that where the card the merchants in those zip where the card member can go and do the transaction. So that immediately reduces the problem from those million merchants to a set of manual list of 200 to 500. Next comes this second part, which is called the ranking of those 200 to 500 now, as to how do I go about in doing the exercise. First, I will talk about the objective function. It is a multi-layered objective function, which is the middle point out here, which you remember I talked about fulfilling two objectives. The first objective is that I need to ensure that I influence the perception of coverage. As an individual, for example, if I am used to taking coffee in Starbucks, question is the fact that can American Express give me a good recommendation with a good incentive so that I can go and not only have the Starbucks coffee but also go and have a coffee on Costas as well. So beyond Starbucks, can I recommend another merchant, coffee merchant, to Jayatu so that Jayatu can go ahead and give him enough incentive so that Jayatu can go ahead and do a transaction in Costas as well. So that is one part of it. The second part of it that we need to keep in mind as well is the fact that is it a cannibalization question? In other words, Jayatu stops spending in Starbucks and starts spending in the case of Costas. That is not something which we want. What we want to ensure is the fact that Jayatu goes about in transacting both, continues in Starbucks as well as in the Costas coffee as well. So that is also the point that, so it is a multi-layered objective function that we are talking about here. Then I will come to the part in terms of advanced machine learning. When I talked about advanced machine learning, that is, everybody uses the word advanced machine learning. It is a term now which is being used at almost in every presentation that we see out here. But honestly, here we try to keep the technique something which is very, at this point we are using a boosting algorithm, primarily cat boost. The reason we are using cat boost out here is because lot of our information, lot of the variables that we have here are variables which are essentially, ordinal in nature, where they are, the variables have a value of 1, 2, 3, 4, 5. And those types of information is getting used for this particular purposes. We have a lot of qualitative information which has been represented in the form of dummies. As a result, what we found is cat boost as an algorithm helps us to sort of drive that outcome better in terms of deciding that which is the next merchant Jayatu has the most likelihood to go and transact and essentially will drive more incremental spend in the process. The type of features that we are currently, the type of data that we have at this point of time is basically, that is where essentially we take a lot of pride, and this is a decision which has been made by our predecessors in the company, whereby we have preserved we preserve every year all the transactions for our customers, whereby we not only know which merchants the customers have transacted, how frequently they have transacted, what has been the velocity of transaction, and what's this average rock size of this particular transactions, and all those details for our customers is something we have preserved. And from there, we have gone ahead and created necessary variables, which essentially goes about, features which goes about in sort of driving this particular objective function. And finally, when we are talking about, contextual features, contextual feature engineering, this is keeping in mind the fact that when we buy external data and we figure out the fact Jayatu as an individual has just gone ahead and bought a house, for example, there is a mortgage trade that we see in the case of Jayatu, then what is the necessary recommendation that we need to give, given that I know that particular information? In other words, if there's a life stage event, I am deliberately trying to stay away from the fact that, the moment I go and buy a house, immediately a sort of a pop-up comes that now I can buy stuff from the construction company at a much higher discount. I think that the real-time fact is something I'm keeping aside. But basically, when the bureau updates this information, immediately we get to hear about it, and that information feeds into my framework in reasonable time in the course of, say, 12 hours to 24 hours, and then automatically the algorithm updates and provides the necessary recommendation. And finally, the test and learn framework. This is something where I would possibly spend 1 minute of my time. There are two things we are trying to understand here. The first question is the fact that, is it an organic spend? In other words, would Jayatu as an individual would have anyway spent, someday try Starbucks and someday try Costas coffee? Or this is something which is happening precisely because of the incentive, because of the promotion I am making to Jayatu at that particular point of time. So we have to go ahead and decide the appropriate test to design to show that, yes, this is being driven purely by the recommendation that we are giving, not by the fact that otherwise the way, the particular customer would have behaved. That is something. So we have control cells with respect to which the comparison is made. That is point number one. Second is also there are some contractual elements that we have with our respective merchants, where we have to show a certain number of offers with them, specifically in the case of promotion campaigns which are supported by or financed by the merchant. So those contractual obligations also come in and baked in the fact when we are selecting those 3 to 5 top recommendations that finally sort of comes in my page. So just to sort of restate this page, while we started with a problem which has a million rows and hundreds of millions of rows and hundreds of millions of columns, and which has a dimension of having having a sort of a time series element to it, we sort of reduce the problem to something really manageable by first applying the locational parameter, then applying the objective function, and finally blending in the fact that what contractual elements that we have with respect to that particular merchant, and made that problem far more tractable, and then go ahead and address this particular question. But having said that, where the part that is coming in is the fact this model is something which is being also built with ensuring the fact we have the right governance structure to it, because that is something where regulators are coming at and questioning us that what sort of information are we using when you are suggesting the recommendation? Are we using any red line information or not? So those types of considerations also kept into mind. So this is something which is run at a very high frequency, almost on a weekly basis. This recommendation system updates at this point of time in suggesting the best recommendations. So that's where we are. So this is the first use case. The second use case is that of auto retraining. Okay, the time is running out very fast. So basically, I'll spend 5 minutes on auto retraining, and the third case I'll spend another 5 minutes leaving time for questions. So so what is happening is the fact that so one of the key questions that we face, particularly in the world of marketing, is the fact that marketing is a world where things are very dynamic. I don't have to say that to you, where essentially everything is changing, the marketplace is changing. As a result, many of the times we have to change. We have to go ahead and modify our products appropriately. We have to give the different set of incentives. We have to change the combination in which we try to particularly push the product to the various channels that we have. So some things where everything changes so fast that it is very difficult for us to come up with very robust targeting models, essentially, which are always accurate all the time. So that is a problem which we are facing all the time. So the first chart on the top talks about the fact that there is a diverse set of offers which are always dynamic, because as I was talking about, that we need to ensure that we give a different set of offers to our card members, so thereby they feel that there is an element of choice. Customer preference also keeps changing precisely because of the competitive offers that are there in the market. And because of all this, what we are finding is the fact that our targeting models, which are used in our profitability logic, keep sort of deteriorating at a very, very fast rate. Okay. Now, if you go to Google in terms of the click-through rate model which Google has, now I don't know, by hearsay, that what I've heard is that that model is trained several times in the course of 24 hours. Now that is something possibly Google can do, but in our world, for us to do that during the course of the day is something which is extremely difficult, because of the fact that any modeling effort, any modeling exercise, be in the world of risk or be in the world of marketing, has to be built with a set of quote unquote very strict governance. And the moment you put those governance principles and governance rules on top of it, it is extremely difficult for us to go and build this framework and sort of sustain this framework in a way whereby our models will sort of refresh itself every few hours. So how did you go about in solving the problem? This is what we did. What we did was the fact that we came up with a mechanism, and this is something which we are doing now. So these are not conceptual slides. So if you look at this particular diagram, the models, so think of a scenario. I'll give a real world example. A model which is put in production, let's assume on 1st of January, which measures the response rate in the MICA channel, which is when the customer goes and logs into MICA, My Card, which is an American Express application, americanexpress.com. They log into their site, and which tells you that which particular offer appears on that particular page. Now, this particular model, which is a response model, my ability to go ahead and my propensity to go ahead and to respond to this product, this particular model that we have out there, that particular model, we rebuilt it on 1st of August, and we have put that in the system. Come 1st September, we have given a bunch of offers. We have given the offer for this platinum card to Jaitu, as well as to several other millions of individuals like Jaitu. Now, the question that we are asking at that particular point of time is the fact now we have 1 month of incremental data, and we have seen the response of how Jaitu has behaved or people like Jaitu have behaved in responding to the platinum card that we are asking Jaitu to acquire with the certain set of incentives? Can we take this information, bake this information, and update my response models? That's where on 1st September, M1 model gets built using the data that we have in the incremental data in the last 1 month, and we build that particular model. And I compare, and we have also the model that is sitting in production as of on 1st of August. Now we have two models. The champion model is the model which essentially is 1st of August model. The challenger model is the model which is the 1st September model. Both the models collide head to head on a neutral data set, which is the test data set that is out here, to decide which is a better model in terms of their performance. Once that is done, once the best model, for example, the 1st September model achieves the right set of criteria saying that yes, it is a better model compared to the 1st August model, that model seamlessly flows into the production, and then that is now the new champion model going forward. Now you might think, okay, what big deal about it? We are talking about several products, 8 to 10, 20, there are 20, 30 products. We are talking about so many channels at this point of time. And we are also talking about several models that feeds into the profitability logic. So together you can think about more than 200 plus models at this point of time as I speak. Every month goes about through this particular mechanism through which the models are compared between champion and challenger, and the right model, quote unquote, the right model with the best predicting power, obeying the standard laws of governance as defined by the regulators, is appropriately selected and pushed in production, thereby ensuring that my models are as accurate as possible. So this is something which we have achieved, what we call as the auto retrain mechanism. This is possibly the first of its kind in the industry, particularly in a financially regulated industry where we belong to, given the fact regulators are always looking over our shoulders at how we are going ahead and doing our job. So, on an ongoing basis, is this something that we are doing in a correct way or not? So that is something I wanted to highlight to you or not, okay? And apart from that, all this information are logged so that if regulators want to track us, whether we're doing the right job or not, that is also appropriately tracked. What has this resulted into? This has gone ahead and resulted into the fact that we have been able to reduce our targeting error by as much as 40% at this point of time. In other words, the model decays at a much more faster rate precisely because of the dynamic nature of it. With this particular mechanism, we have gone ahead and been able to arrest the decay of the model, improve the error rate of improve the accuracy of our model by as much of the margin of 40% at this point of time. Are there opportunities to improve it further? Of course, and that is something which we are currently working on now. This is also another real world example that I wanted to leave you with, okay? And this, at this point of time, again, is something which drives billions of dollars of business for our existing customers in the company. So we are using these models particularly for our cross-sell initiatives, both for the consumer portfolio as well as our commercial portfolio. SIC-8 industry classification. This is a very sort of a, what should I say, a very simple problem which any of you would immediately understand. The SIC-8 at this point of time, if I look at this particular set of figures, the first two digits at this point talks about it is a retail trade. The next 4 digits talks about is an eating place. This next four digits which we talks about the eating place is something which is called SIC-4. This was provided by the US government way back in 1937, and subsequently we have added other digits associated with it to ensure the fact we can really go ahead and say it is an eating joint, it is a Mexican eating joint, or it is an Indian eating joint. So we have gone ahead and classified a particular merchant to its last degree of detail as possible. Now this information is something which is used extensively for our recommended engine problem that I just talked about in the earlier case. Why this is extremely important? The attribution of merchants to the right industry is extremely important precisely because of the fact that we give lot of bonusing offers throughout the course of the year, which is close to $1 billion at this point of time, that you spend 2x times and this is the amount of reward you will get. You spend 3x times, this is the cashback you will get. So the attribution of the merchant to the right industry is extremely important. Otherwise, we will also go, if the attribution is incorrect, then we have to go ahead and give the benefit of doubt to the customer, and in the process we end up losing a lot of money, because that is something as per our agreement we have to go and give the benefit of doubt to the customer. Say, you know what, you said that this is a merchant I can transact, and this is something I will, even though the merchant might not be in the right industry where we actually wanted the industry spend to be driven. So that is one thing. Next point is a shop small. This is also a very important campaign, a very important initiative for American Express. where we are trying to promote the small businesses and getting our card members to know that these are the small businesses, the eateries, the restaurants which are there, and trying to support them. In that case as well, the small businesses has to be attributed to the right industry. So industry attribution of our merchant base is an extremely important problem. I hope all of you understand that is something, you know, and this is something which needs to be done for those hundreds and millions of merchants on a regular basis. Now, how do we solve it at this point? There are three sources of information that we have. The primary is the internal sources. Whenever a transaction happens at that particular point of time, I do capture some sense of that information from my transaction system. Also, I have the information when I signed up the merchant maybe years ago. That is the information which is the lowest quality, because at that point, the sales agent who signs up the information at that point goes out and hurriedly puts some information out there which might be incorrect in terms of attribution of that particular merchant to which industry it belongs. As a result, we buy a bunch of external data, which I think my previous presenters were talking about, and we spend millions of dollars on doing that. And finally, the last is where we applied some amount of data science, which is text-based analytics by reading the merchant name and trying to infer what industry it belongs to, and also as the spend activity which is happening at the merchant. From there, trying to get an understanding what, given this is the spend activity, this is a pattern of spend for this particular merchant, what could be the industry to which this merchant belongs to. We have information from all these sources, and for any specific merchant like region C, we'll have some 10 or 12 sources of information, and then we push this information through an attribution logic, which is a neural network logic at this point of time, which takes all this information and then finally decides which particular industry this particular merchant will belong to. Now, this is something which is being done at scale for these hundreds of millions of merchants at this point of time in order to ensure that I end up doing the right level of attribution. So the point I want to highlight out here to all of you is the fact that what matters here is the marriage of good data, which is the different sources of data I talk about, and the right analytical technique, which is the neural network technique at the end, which just goes about in combining that information in helping us to do the attribution. The top part talks about the spend-based information that I'm using is that the card member, how many times the card member has visited the merchant, what is the type of spend, how much distance it is away, what is the size of the transaction, etc. The text mining aspect which I talked about, and finally the attribution logic which talks about at the bottom of the page, which runs its logic from these different sources of information and then attributes that merchants to a particular industry. Now, this is extremely fundamental, as this information is something which feeds back, suggests the best recommendation, which I talked about in the first case, gets used in the risk use cases which my colleague Shankara talked about. So this is something extremely fundamental. That's one of the use cases that I talked about. Where we are today at this point of time, these are some of the use cases that drive billions of dollars for the company at this point as we speak. Okay, where we have made the problem tractable, combining the data and the machine learning technique to drive the outcome for the business. There are many use cases which are currently in the lab at this point, which we are trying to work on, which will produce the next generation of innovation. The final thing is that we are ensuring the fact whatever we are doing under the broad umbrella of regulation, so that we can sort of go ahead and satisfy the requirements of the regulators are putting for us, so that we can keep pushing the envelope. So that's all I had.